Okay, pre-calculus. We are going to do some review today on quadratic functions and graphing them in their three forms. So you'll probably need your graphing calculator just for a couple things we're going to do today. So you can pull that up if you've got a TI-84, great, or if you've got a TI-84 on your Chromebook, that's fine as well. So let's go ahead and I'm just going to quickly brush through this to make sure I can get this finished in 15 minutes. But let's go ahead and analyze, take a look at this graph. The vertex is at 0, 9. So that means the axis of symmetry is vertical, right? That'll be x equals 0. It's right here. It's the y-axis, so it's x equals 0. The domain, you can put anything you want in here. So that's negative infinity to positive infinity. So that means the range is from negative infinity all the way up to and including 9. So we are going to use hard brackets. For increasing and decreasing, you want to use always open parentheses because we are not going to include a turning point. So where is it increasing? It's increasing, or it's going up from left to right, because we read from left to right, so we do math from left to right. It's increasing here from starting at this, there's an arrow. So it's going from negative infinity all the way up to what x value does it turn right here at x equals 0. So it's increasing from negative infinity up to 0. Now we're not going to include 0 because it's something having to do with something you're going to learn in calculus. For right now, all you need to know is that you don't want to include it because the slope of the line there is actually 0. It's not increasing. So decreasing, it decreases from 0 to infinity. Now, where is the graph less than 0? We did a lot of this in Unit 1, and if you need help, go back and watch the previous videos. The graph is, come on, where are we here? Where's my highlighter? Okay, highlighter. The graph is down here. You get the point. Okay, below the x-axis, that's where f of x is less than 0. So we have got two parts here, two intervals, here and here. So I'm going to go ahead and write those just like we did in Unit 1. From negative infinity, that's a negative infinity, up to negative 3. Now the graph says, where is the graph less than 0? Not less than or equal to 0. So we are just going to put a soft parentheses there in union with 3 to infinity. And then where is the graph above the x-axis? It is between negative 3 and 3, not including it because it's greater than 0, not greater than or equal to 0. And here are the equations, the three forms of the quadratic equation or functions. We've got standard form, vertex form, and intercept form. Again, this is review from Algebra 2. So we are just going to quickly run through the different ways to graph depending on what form you have. So if you've got standard form, you're going to try to factor and use the quadratic formula to find the x-intercepts. Vertex form, set equal to 0 and solve. And intercept form, parentheses, you're going to set them each equal to 0 because you actually already have the intercepts. So let's go ahead and start with graphing in standard form. So if you've got it in standard form, first thing you need to do is find the vertex, negative b over 2a. So let's go ahead and figure out what's negative b over 2a. Negative b over 2a. So in this problem, it ends up being, I should be writing x equals 1. Now when I plug in 1 into this equation, what's f of 1? I end up getting negative 7. So the vertex is at 1, negative 7. So I'm going to go ahead and plot that. Okay, now let me pick a couple other points here. If I plug in f of 2, what do I get? Negative 5. If I plug in f of 3, I get 1. So I'm just going to go ahead and plot those. 2, negative 5. Okay, so that gives me reflecting over the line there. And there's we already know that the axis of symmetry is going to be x equals 1. I already did f of 1. Got negative 7. Okay, good. Okay, so didn't I have another one? Oh yeah, 3. F of 3 is 1. So I'm going to reflect that over the line of symmetry as well, and I will get another point right there. So then you would draw a nice curve through that graph, and I'm not going to draw these because it's really hard for students to see them once I draw through them. but that's what you need to do when you're finished. Okay, the domain is from negative infinity to positive infinity. The range is from lowest y-coordinate is -7, and it just keeps going up to infinity. Where is it increasing? It's increasing starting at 1. I'm going this way. So from 1 to infinity, and it's decreasing from negative infinity all the way up to 1. Now, to figure out where the graph is greater than 0 and less than 0, you basically just need to find what are those two x-intercepts. And when you have the x-intercepts in the other forms, and it's very simple that you already know them, it's much easier. But if you don't have them, if you've got a graph here in standard form, it's probably best if you just use your calculator. So to find the zeros on the calculator, here are the directions. Second trace and then 0, and you have to do it twice to find each of them. But where the graph is less than 0, that's down here, right? It's between the two zeros that I found on the calculator, from negative 0.87 and to 2.87. And then where the graph is above 0, where is f of x greater than 0, that's from negative infinity up to the first x-intercept, that is negative 0.87, in union with 2.87 to infinity. All right, so now we're going to vertex form. I love vertex form. So I've got two examples here. I've got one that I've already done, B. So we'll look at that after we do walk through number 1 together. So we're going to identify and plot the vertex point of the parabola. Okay, so that's given to us in the equation. It's at HK. So H is -2 in this problem, and K is -1. So let me go ahead and write that in. -2, -1. Axis of symmetry then would be x equals -2. So let me go ahead and plot that, -2, -1. Okay, so that means it's going to be opening up. Our domain is negative infinity to positive infinity. Let's wait for the range. So now really all we need is a couple points. We could, g of -1 is 0 and g of 1 is 8. So let's see, -1 is 0. So that gets us also this point, g of -3 is 0. And then g of 1 is 8. Okay, so I'm just reflecting that over, here's the axis of symmetry. So I'm just reflecting it. Let's see. There we go. So then in a different color, I will go ahead and graph for you. Ooh, that's terrible, but you get the point. So the range is from the lowest y value is -1 up to infinity, and you're going to include that point -1. So it is increasing from what's the x value? Looks like -2. -2 to infinity, and it's decreasing from negative infinity up to that turning point at -2. Where is the graph less than 0? Where is it below the x-axis? Between -3 and -1. Where is it above the x-axis? From negative infinity up to -3, and also from -1 up to infinity. So here's the second example. If you'd like to go ahead and take a look at this on your own, you may. I used the calculator to find the zeros and then plugged it in here. All right, so I already had the zeros here, right? They were nice points. Okay, so where am I at? Moving on. All right, we're moving on to example 4. I'm going to do the same thing here. I'm going to go through A with you, and then I already have B done, and you can check that just to make sure we can get in this video in 15 minutes. So when you're given a graph in intercept form, they've already given you the x-intercepts. So if you go ahead and set each of these parentheses separately equal to 0, you're going to get your x-intercepts. One's going to be at -4, the other one's going to be at, -4, and the other one's going to be at -2. Okay, right there. To find the vertex, the x-coordinate is directly in the center there. Here's the x-coordinate. It's going to be on this line somewhere. So I'm going to go ahead, and if you average those two numbers, that's what this equation is. It's just averaging P and Q. You're just averaging what are the two x coordinates. So your x is going to be equal to -4 plus -2 divided by 2. You're averaging. So, or you can just count. It's going to be a -3. What happens when you plug in -3? So f of -3 ends up being 2. So I plot that, and that makes sense because it's going to be opening down, and we've got a negative in front, so we are good. And that's really all you need, but if you want to, you can go ahead and plot one more point. I would say maybe f of -1, and you get -6, and then take -1, -6, and then you reflect it. I want to make sure, and then you just draw a line through it, and then you'd fill the rest of this out with the information that you just, -3, 2, right? And the axis of symmetry is then going to be x equals -3. The domain is -infinity to +infinity. Geez. The range is from -infinity all the way up to and including the highest y value on this graph is 2. It's increasing from -infinity all the way up to that turning point at -3. And decreasing from -3 to infinity. Where is the graph less than 0? Not less than or equal to. Less than 0. It is from -infinity up to that first x-intercept, which is at -4, in union with -2 to infinity. Where is the graph greater than 0? Where is the graph above the x-axis? Between -4 and -2. Checking that to make sure it's right. Good. Okay, so moving this one over. If you want to take just a second, press pause, see if you can do B on your own, and see if you get these same answers. The last problem here is the only thing I think that you might have not learned in Algebra 2. I don't know. I haven't taught 2-trig, so I don't know if you learned this in 2-trig or not. But you are not going to mind this. As long as you know this equation here, the general form, vertex form, when you're given the vertex and a point, let's just go ahead and I'm going to rewrite f of x as y equals, okay, we don't know what a is, but we do know that this is our h and this is our k. Our x, so it's going to be x plus 2, because our h is -2, and then squared, because it's a quadratic, and then, what is it, plus 6 for our k. Okay, now I've plugged in the vertex, so now I'm going to plug in the point. The point, this is our x, and this is our y. So we'll go ahead and plug that in, so I get -2 equals, I still don't know a, but I'm given my x coordinate is -4. So now all I don't know, my only unknown is a. So I'm going to go ahead and square inside this parentheses. That ends up being a -2, but once I square it, I end up getting a +4. So I'm going to rewrite this equation as 4a plus 6. That makes a -2, and now I can rewrite my equation. You need to have a y and an x, because that point, there are multiple, an unlimited number of points on your graph. So y equals, here's your a, x plus 2 squared plus 6. There is your general form of that equation right there. And if you want to try the second one, go ahead and try it now. Press pause. Here are the answers. So my first step is I went ahead and I plugged in my h, my h and my k. And then I went ahead and plugged in my x and my y. Still don't know a. Solve for a. Here's your a. And then rewrite your equation with your x and your y, because this is only one point on your graph. If you want to have a graph with multiple points, you need to leave that x and y open in your equation. And I think that is all. Peace out.